Hi everyone, this is Anton Salati and welcome to your first tutorial on Honeybee generation. Honeybee generation is a set of components within Honeybee which you can currently find under the last tab in Honeybee, which for the first time allows you to interface with and use the Energy Plus energy generation objects. At the moment, only Energy Plus photovoltaic generators, seen in this component here, and Energy Plus wind turbines are supported. However, in the future I'll be adding all the Energy Plus energy generation objects like fuel generators and hydroelectric turbines. Now what I'm going to do today is I'm going to use this example Rhino model here to show you how to put Energy Plus PV generators on Honeybee zones and also on context geometry in a model. In addition to that, we'll also create a wind turbine, and then what we'll do is we'll simulate the energy output of these energy generation objects, and we'll look at their financial value. So let's get started with the PV generator. So first things first, let's create a Honeybee zone let's create a Honeybee zone first so that we can put a PV generator on it. So come here, this is my example model, and let's make this building here. Oops, select it right. Let's make this building here a Honeybee zone. So that's our geometry. Now we need to go Honeybee masses to zone, Boolean toggle. So now we've got our Honeybee zone. So what we need to do now that we've got our Honeybee zone, is we need to select the surfaces within this zone. So get the component select by type, connect the Honeybee zone up, and then we'll want to do Boolean toggle of show roofs. And yep, that should work. Okay, so now we've got just those two there. And okay, so we've got two surfaces. Now let's just put this geometry is not really complicated enough for this example. So actually I'll change my geometry to this one here. Sorry about this. Okay, good. Alright, so we've got, in this case here, yeah, okay, so now we can see that's the roof there, and we want to select, let's say, this part of the roof and this part of the roof. So what you do is you need to do the select Honeybee item selector, and then it's a bit of trial and error. Okay, so that particular trim surface is that part of the roof there in green. That's another part. Okay, that's another part. No, we don't want that part. Okay, so that's one part we want there, and then we'll do another. Select by surface, bring this in, and I think, yep, there we go. Okay, so we've got those two parts there. So let's add PV generators onto this part of the roof. So you get this component. We put these two surfaces into Honeybee surface. Now these are the properties that need to be specified for these PV generators. So a PV generator will be made on each surface. So for every surface here, one PV generator is made on that surface. So the first property is the surface area of the solar cells. So what percentage of these surfaces here are covered in solar cells? That's what this is asking here. So let's just make it 0.7, and if you hold over the documentation here, it will explain what each input is. Now, an important point that I'll make here is that if you've got several Honeybee surfaces coming in, the values are assigned sequentially. So that means that if I've got 0.7 here, 0.6 here, what that means is that if I come over, what's the first? Okay, so this surface here is the first surface, so that surface. So that means the first surface will be assigned, this surface here will be assigned 0.7, whereas the second surface will be assigned 0.6. Now, if I was to take away 0.6, then the second surface is simply assigned 0.7. And in fact, if I was to have another surface, this will also be assigned 0.7. So if I was to also do this again, what that means now is that the first surface has 0.7, the second surface has 0.6, and the third surface has 0.7. So if there's no, if there's a surface and it's not assigned anything, it simply defaults to the first value for each input. Now let's look at the efficiency of the cells. So let's just go with 0.12, so 12%. Okay, now the integration mode is something that's quite complicated. I won't go into detail what it is here. Just have a look at the documentation. Okay, so now we're interested in the number of modules in parallel and series. So how this works is that there's one PV generator on each surface here. Oh, it looks like I've selected one surface twice. There's a PV generator on each surface here, and that PV generator is made up of one or more PV modules. So let's just say that each PV generator has 2 modules in parallel and 2 modules in series. Now we've got the cost per module. So let's just say the cost per module is 300. So what that means now is that the cost of each PV generator will be 4 times 300, 1,200. At this point, you also don't need to specify the currency. You do that later. Now, the power output per PV module, let's just say it's 300, so you've got $1 per watt. And at this point, it will be 4 times 300 watts, so 1,200 watts. Now, the last thing is each PV generator must have an inverter connected to it, because at this point, solely DC systems are not supported. So come up to Honeybee. Again, go Honeybee Simple Inverter. At the moment, I only have simple inverters, but in the future, I'll add the other Energy Plus inverter types. Connect it up there. You need to give this inverter a name. So let's just call it Inverter 1. Okay, there we go. The inverter efficiency, 90% is the default. The inverter cost, let's say it's $2,000. Oops, wrong. Okay, $2,000. That's inverter cost. The replacement time, so how often do these inverters need to be replaced? Let's just say once every 5 years. Okay, so now we've got 2 Honeybee surfaces, and if you want to know, 2 Honeybee surfaces with 2 Honeybee PV generators attached to them. So if you want to know the details of each PV generator, you can actually come up to this README here, and there's a data tree. Okay, so let's see, the first PV generator is PV generator 0. It's been assigned a default name. We can actually change that here. So let's just call it generator 1. And then we'll create another one, generator 2. Put that in there. Okay, so you can see generator 1 is mounted on Honeybee surface, so that's the name of the surface. Generator 1 has the following properties. So remember we assigned 0.7. So solar cells of generator 1 cover 70% of the surface area of Honeybee surface. The solar cell efficiency is 12%. Yes, we assigned that here. The integration model is decoupled. The integration mode is decoupled. Again, have a look at the documentation on that. The number of PV modules in parallel is 2. The number of PV modules in series is 2. So generator 1 is made up of 4 PV modules. The cost per PV module is 300. Therefore, the total cost of generator 1 is 1,200. The power output is 300, and the total power output of generator 1 is 1,200. So now the second one, remember we 0.6, so it's 60%. We can also change this here just as an example, so we'll give it 12.15% efficiency. Okay, there, the integration mode is decoupled. So because only one value is input here, you can see that it just defaults, all the other values just default back to the value of the first generator. Just an example here, I'll just quickly connect a third surface. Yeah, that will do. Okay, and we'll connect it in here. Okay, so now we've got a third surface, and you'll notice that the third surface defaults to all the values of the first surface because I haven't specified, there's no third value in any of these inputs here, so that's why it just defaults back to the value of the first. Okay, so that's the first part of actually creating a set of PV generators. How am I doing for time? So what I'll just do quickly now is connect it up to the next part, which is a Honeybee generator system. So all your PV generators and your Honeybee and your wind turbines need to go through this component. So connect the PV surfaces here to PV Honeybee surface. Now you need to give this generator system a name. So PV on Honeybee zone, call it. And because Honeybee generation does financial costing, let's give it a maintenance cost of, I don't know, maybe $400 a year. Okay, so now what you actually do, the next part there is you connect that up to Energy Plus for it to run. But let's stop this tutorial here, and I'll continue on the second tutorial where I'll just quickly add a Honeybee generator on a context surface and also a wind turbine, and then we'll simulate it in Energy Plus. So be right back.